Welcome to Ultrasound Physics Lab Session 1. Today we're going to talk about ultrasound machine knobology. What's knobology? It's the functionality of the controls on the machine. Let's get to work. This machine is a GE Logic S7. Most of our machines have the same configuration: a control panel, a touch screen, and a monitor. The control panel has the keyboard, the trackball, and various other controls. You use the keyboard when you want to annotate or label things. The trackball functions similar to a mouse. You push the arrow to get the cursor on the screen, you move it around. The trackball keys have different functions depending on the exam. A couple of the other controls on your control panel is the freeze and the print. You'll be doing a lot of that. Freeze, print, freeze, print. This one labeled B here for B mode is actually the gain. You can turn up the brightness or the strength of the signal. Here's your depth. You can adjust the depth of your image. Above the control panel is the touch screen. The touch screen has various controls. On the right side, you can choose which transducer to use. The other controls change as you change the transducer and as you change the type of exam. To the right of the touch screen is the TGC. The TGC allows you to adjust the gain at various depths on the image. The monitor, of course, is where your image appears. On the lower left-hand side of the monitor is a diagram. It's pretty handy. It shows you what all the trackball keys are according to your exam. Okay, let's do a case. What's the first thing you do? The first thing you do is you put the patient's name in the machine. How do you do that? You go to the touch screen and you hit patient. The patient demographic page appears on the monitor now. On the top is where you enter new patients. On the bottom is old patients. Those are patients, they can keep about a year's worth of patients. So, using your trackball and the keyboard, you enter the patient ID, the last name, the first name. For our purposes, we won't be doing any real patients, so you put the scanner first and you partner the patient second. So here I would be scanning a patient named Joe. Okay, then you use your trackball to hit save and exit, and we're good to go. Okay, you got your name in the machine. Now what? You choose your probe. Which probe? Depends on what kind of study you're going to do. All right, let's say I'm going to do a cardiac study. For cardiac, you use a sector probe. Get into the cardiac package. Let's pick adult. Okay, let's do a vascular study. Okay, for vascular, we use a linear probe. Go to vascular. And let's pick lower extremity venous. How about OB? I want to do a pregnancy. Okay, OB. Let's use a curvilinear probe. OB. And let's go first trimester. How about abdomen? Okay, abdomen. We keep the same probe, curvilinear. Just go to abdomen. Okay, finally we're ready to scan. I've got my imaginary patient here, Joe. Got his name up here. I got the right transducer. I'm on the right preset. Get a little gel. Put it on. Let's go. Remember, you're scanning with your right hand. You're doing the controls with your left. If you're left-handed, you're just going to have to adjust. Scan with your right, controls with the left. Okay, we're finally scanning. Looks kind of dark though. Maybe we should turn up the gain. Gain? What's that? With gain, you're amplifying the signal after it gets back to the transducer. You see, when ultrasound comes from the transducer, it starts off with pretty good power, and then it gets absorbed, reflected, refracted. That's called attenuation, and it gets weaker and weaker. Here it is, it hits the cyst, and then it comes back weaker and weaker and weaker back to the transducer. What gain does is amplify it once it gets back to the transducer. Output power is another control that we have. Output power controls how powerful it is when it comes out of the transducer. Gain controls how much you amplify it when it gets back. Okay, it starts off high power, high amplitude, gets back low power, low amplitude. Output on the way out, gain once it gets back. We don't adjust the output power that much, although we can. We usually just use the one that comes with the preset, but we adjust the gain a lot. In some of the machines, you can even adjust the gain after you've frozen the image. Wait, it looks good, but the deep structures are kind of dark. Maybe we should adjust the TGC. Okay, that's better. TGC?
What's
TGC is time gain compensation. It's also known as DGC, depth gain compensation. Same thing. You see, some of the sound doesn't have far to travel. If you're imaging something close to the surface, the sound comes in, comes out. There's not much attenuation. Then if it goes a little bit farther, it comes back, it's even weaker. If you image these structures that are way down here, it has a long way to go and it loses a lot of power along the way. So you have to have higher gain for that one. So what do? The structures that are close, we have low gain. The structures that are farther away, progressively, we amplify them more. TGC. DGC, depth. TGC, time. Why time? Because what the machine knows is the sound that comes back really quick, it doesn't get much gain. The sound that comes back a little bit later, it gets a little more gain, and so on. So TGC, DGC, same thing. So I guess you think that you're supposed to set your machine like this, your TGC like this. Nope. The manufacturers want you to start your TGC out straight up and down. They've already built in that slant into the presets. Now, if you get somebody that's a little heavy and they might need a little help in the far field, then you can adjust it. Oh, too much noise in the near field? Okay, you can adjust it there. But start off with it in the middle. Here's something that happens all the time. Here's a carotid artery. Okay, I'm going to use my TGC and kind of clean it up a little bit. It's a little bit noisy in the carotid. So here's my TGC now. I turned it down in the middle to get rid of the noise in the carotid. So the next tech comes along and does a liver. And look, there's a big stripe down the middle of my image. The near field looks good, the far field looks good, but right in the middle it doesn't look so hot. Look at your TGC. Yep, it's left over from the carotid. So always put your TGC back to straight up and down. That's a little better. Okay, we can change the quality and the brightness of our image by adjusting the gain. We can also change it by changing the output. What's another way we can do it? Change the frequency. I know what you're thinking. Wait a minute. How can you change the frequency? In the third chapter, page 21 of our book, it says, no, the sonographer cannot change the frequency. So why is there a frequency knob? You'd think the only way to change the frequency would be to change the transducer. But you'll notice in every transducer, there's a range of frequencies. This one's a 1 to 6. So probably what's happening when you change the frequency, it's something on the receiving end, and the machine is choosing to receive a certain range of frequencies. At any rate, when you lower the frequency, you get more penetration, but it gets a little grainier. Higher frequencies are best for superficial structures, like this thyroid. Okay, finally I'm scanning my patient Joe here. I got the image I want, I adjusted the gain, I adjusted the depth, I adjusted the frequency. Okay, I got a good picture of the right lobe of his liver. Freeze. Now I want to label it. How do I do that? Easy. I hit comment. Then I go up here to the touch screen. Let's make a supine, liver, right lobe. There it is. You're labeled. I can also use the keyboard and write anything I want. I can also move it around with my trackball. Put the label anywhere I want. Okay, I froze my image. I labeled it. All I gotta do now is print. So there's the image you took on the upper left-hand side there, and I can keep adding them, keep taking pictures. Do that about 20 times, and you gotta study. End exam. Here's all my images. Select all. Save as. So your images are in a file. In the hospital, we used to send them to the PACS, and the radiologist would read them. You can burn a disk. In our case, we're going to put it in a flash drive. You get to take the flash drive, you put it in a PowerPoint, and you submit it to your teacher. And that's one of the ways you're graded. One of the hardest parts of the study is finding where to plug in the flash drive. Here it's easy. Just put it right in there. This one's over here. This one's on the side of the touch screen. You get the idea. Well, that about wraps it up. Thanks for tuning in, and I'll see you in lab.